Alright, here's one more example of this type of probability. It's a little bit different. So 5% of electric light bulbs are defective at the manufacturer. If 6 light bulbs are tested, presumably randomly, with each one being replaced after being picked, what is the probability that 2 of the 6 are defective, or at least 1 is defective? And first off, there's a couple of giveaways for why this problem falls into this category. And the first is, well, it's either defective or not. And that's the first thing for binomial. So let's set this up here. Probability defective (5%). And so that'll be the A in the problem, and then not defective 95%. Okay, so that's the first giveaway. It's either or, one or the other. Now, second off, you've got 6 light bulbs being tested, and you might think, well, perhaps this is a tree diagram with a bunch of branches, and you could do that. But it gets a little, I went through the trouble here. I'd be like the first one defective or not, the second one defective or not, and then by the time you get down to 6, it's too much work to do it, and it's not worth it for these 2 problems. So that's why the binomial, this Pascal's triangle method is more useful here. Now, this also is important. Each one is replaced, so this won't change. That's pretty important. If you remove something from the pool of objects that you're picking from, that does change the probability of what's left. So that can't happen. So that's sort of a caveat there that has to be there. Okay, probability that 2 are defective. This would, just for the sake of setting this up, this would be like 0.05. That's our A. That's our B. And 6, this is going to happen 6 times. So this time it's going to be to the exponent 6. And obviously that adds up to 1. So everything included is 100% chance of something happening. But if we want specifically this potential outcome, probability 2 are defective, implying 4 are not, let's go ahead and just calculate that. So X is going to be, let's say X is how many defective in this case are defective. So probability of X is 2 would be, let's see, without writing all that out, it's going to have the binomial coefficient, that's the number from Pascal's triangle, and there's going to be 6 because there's 6 trials, and we want the one that is 2. You could put a 4 down here because we could have called the 4, we could have relabeled this differently and it would still work out. Call X, the X could have been the other way, the amount of not defective light bulbs, but we kind of picked it, so let's start with this. 0.05, 0.05, and 0.95. Those are the, it's either one or the other. And we want 2 of these and 4 of those. And so we just got to figure out these numbers now. So this is 6 factorial over 2 factorial, 4 factorial if you want to do it by hand, and then times these numbers right here. So let's just figure out, well, what are the decimals that we're dealing with? Okay. 5, we want 2 that are defective, 5% chance, times 95. We want 4 of those, so it's pretty slim. 0.002. So 0.2% chance of this particular thing, but we do have a number of different rearrangements of 2 and 4. defective and not defective. So let's do this one here. I'll do this by hand. 6 times 5 times 4, 3, 2, 1, 2 times 1, 2, 1. Let's cancel, and then that would be 3 over 1. So really this is 15. There's 15 ways to do this. 15 times our probability of any one particular branch from the tree diagram. It's like there's 15 branches, each with a probability of 0.2%. Not what I wanted. 15 times. And we're going to multiply it. 15 ways times each way having a probability of 0.2% is about 3%. So, probability x is 2. Zero to 3, 3%. I guess if we round it up, it would be 3.1. All right, now the probability that so that was the first part of this. Probability there are 2 defective, and that implies exactly 2. Didn't say here that there's at least or at most. This does say at least 1 is defective. So that'd be 1, 2, 3, 4, 5. Really leaving out, the only situation left out is the situation where all 6 are not defective. So rather than expanding everything and adding it, let's instead find the probability of a situation where none of them are defective and subtract it from 100%. So let's go ahead and do that. So probability x is greater than 0 is really what at least 1. X, the number of defective, is more than none. That would be p x equals 1, probability x equals 2, and so on. I'm not going to do that. Instead, I'm going to take 100% and subtract the scenario where all of them are not defective. And this 6 choose 0, none of them are defective, and all of them are not defective. So got my numbers in there right. Okay, so this is 6 choose 0. That's going to be 1. It's the first number in this in the row that in Pascal's triangle that's got the 6 with it. Time this is 1, and then let's calculate that. Okay, so 73.5%, but we actually want the opposite of that. We want everything else. So it looks like 26.5%. So this one was the 73.5. But then 1 minus 73, that was 26.5. Okay, I made a little mark there, but ignore that. X greater than 0, so 26.5%.